Welcome everyone to our Temporal Community Live. Really excited to have you all here. We've got two great talks today that I'm really excited to hear about. So I've got a little deck to kind of go through the agenda, say hi, and then I will hand things over to our speakers. As always, we're going to be keeping an eye on the chat. So if you've got questions, chuck your questions in the chat, and we'll go through them in the Q&A section near the end. And if you've got any comments or anything else, feel free to chuck them in the chat, and we will do our best to help as well. All right, let's keep on rolling. So we've got two presenters today, and I guess me as well. So Simon is a staff solutions architect here at Temporal. Simon's going to be going first. And then we've got Luke, who's the co-founder and CPTO at Architect as well. And so some really great speakers today. I think they're going to be really fun. In terms of agenda, Simon, well, we've got the intro section, which we're doing right now. Simon is going to talk about putting humans in your workflow. And then Luke is going to talk about Architect's agent orchestration layer. And then when we're done with both of them, we will jump right into the Q&A where y'all can ask us whatever questions you have. And I'll be reading the questions, and then Simon and Luke will be answering them. And then if we've got a little bit of time at the end, Simon is going to go through our product roadmap to give you a heads up of what is coming in the future in terms of Temporal. Simon, I think that's your cue. If you want to go ahead and take over the screen share and get rolling.
Yep, I shall absolutely do that. Replace current screen share. I can control this. I can control shy. Ha ha ha.
I
That's
see
all
you.
good.
It looks good. Sounds good. So
Yeah.
take it away.
Excellent. Hello, everybody. Oh dear, hang on. That's what I wanted. Hello, everybody. Yes, I'm Simon Ems, Staff Solution Architect at Temporal, and today I'm going to be talking a bit about another feature of Temporal, which is how to put a human in your workflow. Now, there's a lot of reasons why you might want to do this, but fundamentally, it's imagine a process that needs manager sign off. So you'll have lots of things that are going along which can be automated, and the automation process continues as you expect. But then at some point, whether it's because of a certain level or just because you want everything to have a human to sign it off and to approve it, this is where the human in workflow comes in. So there's some use cases for a human in workflow. So I like the picture of a nice Monty Python judge because this is effectively you get a human who's judging this. And I thought a picture of Terry Jones in his wig would be a most appropriate way of expressing that. So you might want to have a loan application if you're doing a banking situation. You might have a particular level which you say, we want this to be automated, and then above that level, we want the human to be able to do something. If you're doing content moderation, you might be able to, with all the magical heuristics with AI, you might be able to get, I don't know, 80, 90, 95, 99% done with automation. But then you might have things where it says, we're not sure about that. And you say that has to go through to a human to get the final decision, to give the overview and to give the okay or the rejection to it. If you've got compliance, there are certain things which may be outside the scope of legislation with AI and what you can do automatically. So you need to get a human to do the final sign off. And in this one, I've called this cryptically non-automated status update, which is what my demo today is going to be on. So I'm going to just leave that there, and I'm not going to explain it too much at the moment. When it comes to this, humans aren't an afterthought in your workflow, they're first-class citizens. So as engineers, we tend to think of things that we can put together and we can unit test. You can't unit test a human, but you might need to allow them to have access to this workflow and to actually be an integral part of it. So this is what we're going to be talking about as well today. And Temporal's a great fit for this. There's a little clue on the picture as to what I'm going to be showing. But the reason why Temporal is a great fit for this, because workflows can last a very long time. I've mentioned in previous meetups that we've got customers that have workflows lasting for many years. And it could well be that you need to get the human as part of that loop in there. We had a banking customer a couple of weeks ago that I was talking to, and they wanted to have an automated approval change that if it if within the first 2 days, a human could approve it, but then if it exceeded 2 days, then the workflow would auto approve. And that was their use case, and Temporal was a great fit for that. With Temporal as well, everything is auditable. The full history is maintained, and the decision that the human makes is just as much a part of that workflow and the records of that workflow as anything that we automate as well. It's flexible, so you can easily accept many sorts of approval, whether that's from a web application, something like Slack, or even if you've got something like an IoT device, where you need to be able to have that to come back and make triggers to say, please go and do a human interaction as part of this. And the state maintenance is really easy. So in my previous career as well, I've done lots of work with WebSockets to do real-time manipulation of applications. And you can do that very easily with what we're doing here. But with the workflow having a particular state, that makes a lot of things as part of the human in loop process much easier. This can be used to track progress and status for users. So this is what we've got on screen here. This is a very simple flow chart of a workflow. And this is a request loan workflow. So I go into my bank and I say, hello, can I have a loan? And it goes through a series of automated checks. If I'm saying I want to borrow £5,000, then the auto check will say, yes, Simon can afford £5,000, or no, he can't. And if it rejects it at the auto checks, then that loan is rejected, and there's nothing I can do about it. And I've been rejected for that loan. If it goes through, we have then a decision point, and if the loan value is under £10,000, then once we've got to here, then we can just rely on the automated checks, and that goes through to the approved stage, and I get my money. I'm very happy, and I can do my kitchen. If the loan is above £10,000, then we have to get a human in loop, because we've got to get manager approval, and that is our banking system. That's what we've said that we've decided as part of our workflow, is that we have to get a managerial decision on anything above our floor limit, in which case this is £10,000. And again, that is still part of the workflow. So if we reject it, that's rejected, and that's rejected in exactly the same way as it was previously here at the auto checks. And if the human approves it, that goes to approval, and then we can continue the additional steps of sending the money and getting that in and setting up the payment plans and all that side of things. So as you can see, this is not, it might sound a fairly esoteric thing at the start, but actually from a business point of view, you can see this is quite a real scenario that people have. Okay, so I'm going to do a demo here, which I'm just going to leave on screen for a moment, the location. So it's github.com, Simon M's Temporal Demos. And then if you go into the food ordering directory, this is what we're going to do. I'm going to show you how my new fish and chip shop allows people to do orders over the internet. So, wrong one, wrong screen. There we go. So this is here on the right hand side. This is my new restaurant, the Grub Stop, and we serve fish and chips, and we serve battered haddock, and we've got various sauces as well. And obviously, being a proud Midlander, I'm always going to have a curry sauce because that's the correct way of doing things. And I'm going to cook for my partner as well. So I'm going to get fish and chips. We've got one bag of chips is enough for the two of us, but let's each have a battered cod because that's nice. So I go and place that order, and this is going to come and be delivered to me. So once I've placed the order, so things that aren't shown in this, I'm not showing you the card process and all the put address in, but just take that as accepted as what we've done. So we've got to this bit here. Now, from on the right hand side, from a user point of view, we can see that my order is pending. So at this stage, it's not been accepted, but the payment has been taken. And in our workflow, we can see that nice and easily. I'll just expand this a little bit. So we can see that the first stage has happened, which was the take payment. We've taken the payment, and that has moved it from the default state into a pending state. And once we've done that, we've then sent a text message. So I've received a text message on my phone that says, thanks, Simon. You've taken your order. We'll come back to you with updates later on. As you can see as well, because this blue hatched line here, the workflow has started. It's not yet completed yet, and this will last by design as long as it takes for this workflow to happen. let's go back. Sean, have you added people into the room? So I had a couple of requests come up. I'm not sure if you're seeing them. If you could do that, please.
Yeah, I think Natalie's actually been on top of it. So
Okay, perfect. Thank you very much. On the right, on the left-hand side, we've now got what's the kitchen's admin here. Now, we see that we've got some orders come in, and if we had multiple orders, these would all be displaying along the side here. And this order here, we can see we've got one curry sauce, one chips, two battered cod. We haven't yet accepted this, so let's accept it. We've now sent an update to our temporal workflow to say we have accepted it. And as you can see on the right-hand side, the status here has gone from pending to accepted. That means that as a customer, I can see that, brilliant, my food is being accepted. I should get my food shortly. And then later on, we can say, right, okay, that's been accepted by the restaurant. And then that comes to the top of the queue and we start cooking. So we've had the kitchen manager has said, yes, we're going to accept it. And then it's gone through to the chef, and the chef has started cooking my fish and chips. And they've clicked through, yes, I've accepted this order. I'm going to start cooking it. And on the right-hand side, you can see now that we're preparing the order. That's brilliant. Once it's been done and it's been ready for delivery, that goes to the delivery people and they receive it and say, yeah, we're now out for delivery. And on the right-hand side, my order says, yes, we're ready. So I can feel that I'm getting quite hungry now, but I know that my hunger is going to be satisfied before too long. And then the delivery person comes to my door, that says, hello, Simon, here's your dinner. Thanks very much. That's been delivered. Brilliant. On the left-hand side, there's no open orders. And on the right-hand side, I've had a message to say, thanks, Simon, enjoy your grub. So we've got, at every single stage, the workflow has been waiting for a human to actually do something and update the workflow so that we can go and do things. But importantly, as you can see, there are also other things that are happening as part of the automation process. So the payment has been automatically done. And then all of the different notifications sent to my text message, those have all been done automatically every time somebody changes the state. We can also do some other things as well with this. So let's go and, I'm still feeling a bit hungry. So let's have another bag of chips ordered. In fact, let's have two, because why not? We do like a chip in the UK, and a bit of curry sauce. Brilliant. So that's been ordered and the payment's been taken of that. But of course, this is now getting on at 5 to 9 of an evening, and they've run out of all the chips. They've done the cleaning, and the kitchen says, look, this is far too late now. So let's reject this order. And we're not going to do this order because that's not part of it. On the right-hand side, the customer has been able to say, we can't do your order, your money has been refunded. And for anybody who was here in my Saga pattern talk last month, they might recognise some of these patterns we have in here. So we've taken the payment, we've made effectively a destructive change, we've taken the money from the customer, and it's gone through the workflow as normal. But because we've rejected the order, we're going to refund this payment. We're going to say, yeah, we can't take this order. We're just going to reject it. But the money that I've paid has been refunded. So the customer, they're not going to get their food, but they're not going to lose money, and that's been done automatically for them. And so as a user, as an engineer as well, Temporal makes this whole process nice and easy for us. Let's have a look at a bit of the code involved in here. So this is actually a relatively straightforward workflow. The workflow here is written in Golang, and we start at the top. And the first thing that happens is we set the order status to default. So the first status that is received is the default state, and that's what happens, and that's just what it is there by default. I'll come back to these next sections in a moment because they're called updates and they're called queries and updates, which I will need to explain in a moment. And then the next thing that happens here is we take our payment and we send a text message and we then wait. So we're waiting for this workflow to receive something that we can then do, which, as you can see, the two things that I'm waiting for is that I want the state to be either completed and that the update is in progress. Oh, sorry, it's not in progress. Sorry, not in progress. That's the important thing here. And then we have two things here called a query and an update. So they're relatively straightforward things to understand. A query is a read-only operation on a temporal workflow, and that will just return some information back from the workflow, which in this case, it is we're returning the state. If I click here, you can see that the state is the collection, the delivery address, the email, the products we've ordered, and the status. And the status just says default pending accepted. It's what we're all expecting to see. So that we can make a number of calls to that as we want, and we can always get them what the current state is. And finally, the important thing is here, we've got this thing called an update. Now, an update is a read and write query. So we write something in and we say we want to make a change to the state. In this case, we want to change the state of the order. We might want to move it from, I don't know, pending to accepted. We can also with this, and we'll also get that result back as well as part of it. But also the important thing with an update is that we can actually validate the data that we send through. So in this case, if somebody says that they want to pass in the status banana, which is not a valid state, then that would come out as an error. So as an engineer, we can't just send in whatever we like. So we've still got some control over the states that get put in. And then once that state gets accepted, we update the state on the workflow, and then here we just send a text message to say that that state has been accepted. So we can add in whatever activities we want at this point here. They just become part of the application here. And it also is how we cancel the workflow on the point of rejection. So we're going to call this refund payment here, and then when this is finished, we're going to cancel the workflow. So you can see actually in only 100 or so lines of code, 130 lines of code, we can actually control the entire state of a workflow and the entire state of our food order just from a temporal workflow. Okay, thank you very much. That is the end of my demo. What we're going to do as before is we'll do Q&A at the end of after Luke has done his talk, and I'll hand over now back to Shelley.
All right, Luke, are you ready to go?
I think so. Can everyone see my screen?
I can
Yeah.
see your screen.
All right, brilliant. Yeah, like Shai said, I'm the Chief Product and Technology Officer here at Architect. I just want to say thanks to Simon and Shai and Nestle for bringing me in to give a talk here. I've been following Temporal for a very long time, even pre-Temporal Cloud, and this is the first time I've managed to use it extensively in production. So I'm going to talk a little bit about agents. I'll get to what Architect is, but we build an AI agent. In fact, we have a few, as well as we have non-agentic AI functionality in our platform. And agents are very, very hard to productionize. There's a lot of moving parts. There's many vendors involved. There's many failure points. Calls to inference price, whatnot. And they're hard because state is hard. Like I don't know if everybody has the same definition as agent I do, but so we're all on the same page. The key thing that makes something agentic and an agent is literally the state that it has, the fact that it is stateful, giving state to an LLM model where it can take actions and then read the result of its actions and then take more actions. And state is hard. State is hard for a whole load of reasons that as engineers we're all familiar with. But agents are a lot more like your database than they are a stateless service, except imagine every time your Postgres database went to its page cache and had to pull something off disk. Imagine that being a call to OpenAI. And I don't know if anybody has the OpenAI status page on subscribe to that. They go down a lot. They go down a lot. There's a lot of fallback and things like that we have to do to make that reliable. Then more related to what we're talking about today, the human complication makes this doubly tricky. There can be many times when a human gets involved in a workflow. You have the product elements, like Simon's been talking about, where you have a workflow that requires human approval or human interaction in some way. But there's also operational elements, and I find this is a big part of it too, where sometimes you may have a bug in your workflow or in a downstream service the workflow calls, and you want to be able to manually intervene and make changes to what's going on, and that can be decoupled in time. Sometimes human approval can come after a few minutes, a few hours, a few weeks, or sometimes never at all. And so you have to really think about, for your use case, how you handle all of those possible cases. But first of all, let me just explain what Architect is. At Architect, we build a platform that puts your website and website management completely on autopilot. So our agent builds all of your pages. It optimizes your pages over time, learns from your customers, learns what they want to know, and personalizes and tailors the page based on where the customer came from, whether that's from an ad, whether that's from a specific link you sent them in an email, or whether they just came to your homepage. Our requirements for our agent are quite tricky because of this, and I'll explain what this diagram means. So if you're a customer of the Architect platform, you go in, you upload all of your information, and then you create a page and you say, well, I want to create a page for this ad campaign or this specific product feature page, whatever it is. That's then going to trigger a temporal workflow where the agent will then run until some user input is required. Oftentimes, when that user input is required, the possible set of user inputs is constrained, it's fixed. And so we can then actually pre-compute the next turns of the agent before the user actually does that, and we can sort of put that in a staging area. This is because for us as a website product, naturally, latency is our number one priority over anything else. So you have a workflow where the agent is running, and then more workflows where the agent is running. There are points where the operator can then intervene and make changes. Our customers who are creating these pages can request an edit, at which point that's another workflow to perform that edit on the page. And what's really powerful about our architecture as to how we make your web page an agent is that the end user can actually then interact. So we have various functionalities like letting the page branch into different sections, or the agent can ask the user a question to tailor the content, or the user can ask a question of the agent, triggering an entirely new path that has to then live or compute live. So there's two options for how you build this with Temporal. You've seen from Simon the single long running workflow. Now, this is really powerful and gives you great observability and failure and resiliency and whatnot. But there are implications, and so I'll give you the counter to the way Simon does it. So there are problems with the single long-running workflow, and Temporal will talk about this a lot. There's things like versioning. What happens if you change your workflow? What if you want to then branch the workflow? Well, do you do that all in the one workflow? What's the cardinality of that? That all gets tricky. The alternative is to keep your workflows short-lived, at which point you generally don't need to worry too much about versioning. It's okay to keep old workers around for a couple minutes versus a couple years, very different. And then I'll talk about how the branching and things like that work in a second. So obviously we go with the many workflows approach, and let me talk about how this works specifically for an agent. So for our agent and for all agents generally, you can model all the possible states the agent is in as a graph, and then you can imagine traversing that graph. So this is what we do. So we store individual state nodes. So a state node has a root state node where that takes in all of the inputs, creates the initial state for the agent. We can then run the agent over and over. I should have put a slide in for this, but we can then run the agent until it then needs some kind of user input. So you can think of it as a function of input and maybe an input event to an output state, output events that it then, is it taking actions on the world? And then for the next run of the agent, we can take the output state of the previous node, the input event that triggers this state node, and then we can start computing these nodes over time. There can be many kinds of inputs, and at any point we are then able to create a new state node on the fly for whenever there's an input event we haven't seen at this point in the tree. And this allows us to merge in real time between completed state nodes that might have been done months ago. They're loaded up out of the database whenever the user traverses through that part of the graph. Or if they ask a new question we've not seen before, we can then just do that live. And from the perspective of our agent, there's no difference. Let's talk a little bit about what's internal to these state nodes. So like I was saying before, we load up the metadata for the state node. We say the state node is now live and processing. We load the parent state node state. We then create our agent in code. And this is another trade-off with Temporal, where you can do it a little bit more like Simon's, where the majority of your state and logic actually lives in activities. This is really good if you're doing that long running workflow. But when you're doing short-lived workflows like us, you can really leverage Temporal for much better observability, where you actually do all of your logic in the workflow itself. And so we can see all of the inputs and outputs to the agent, and each LLM call or call to an internal service is an activity. So we initialize the state of the agent. We can then process the input event. The agent can then turn until it's done. It then produces the final state and the output events. We're able to do cool things with signals to signal between different workflows to stream these events out live as well. I think that's a little bit too in-depth to talk about in this, but could do that as a demo another time. We then write the output state into the database, the events that it's outputted, and then we mark the state node as done. So this obviously sounds quite complicated, and it is to a degree. And so I think I've covered maybe some of these already as to why we do this. But one of the key reasons we did this way was we wanted to avoid any infrastructure and operational complexity of long-running workflows. We're a startup. We don't have a platform or SRE team. Keeping old versions of services around is very difficult for us. And so keeping your workflows as short as possible will help you operationally. If you're a much bigger company, your workflows don't change as much. Those long-running workflows can really give you great observability and whatnot, like Simon showed you. Robustness to code failures is a big one, especially as a startup. Sometimes state nodes fail. We see issues with parsing LLM outputs. We see downtime from LLM providers. A whole host of things can go wrong. Because any state node is simply a function of its inputs to its outputs, we can just run them again. Now, obviously, it's not deterministic, as no LLM systems are. But in our case, that doesn't necessarily matter. And durable execution transparency. Obviously, durable execution is a great term that Temporal use for what Temporal does. But we're able to build a lot of code that is completely transparent to whether it's running in a temporal workflow or not. And we do this through separation of concerns and interfaces and good abstractions. But this allows us to then, we can run the agent in a CLI or in an experiment environment or in a sandbox for evals or whatever it is, while then running it in the temporal workflow in production. There's a few downsides to doing your orchestration like this. So I'll go back to this slide, right? State is hard. Why is state hard? Well, state is hard because when you make changes, you have to think about the difference between your old code and your new code, how it handles state. Particularly at a large size, you might have old and new state side by side, old and new code side by side. When you're a stateless service, you don't have to think about this, but we still have state in this system, right? We have the state of the actual agent inputs and outputs and how that all works. And so we still have to think about that state and how we migrate that state over time. But with this approach, it's all in the database. So we can just write a normal database migration and we can handle state the same way we would handle state anywhere else in the system. Observability is much, much harder. Like I say, if you can do a long-running workflow, you get a lot of this for free. We don't get this. We could have sometimes a couple dozen, but in the case of a lot of questions on a page, we could have thousands of workflows for any given agent run and many, many branches. And that can get very painful to trace through and to find out where things happened, where things went wrong. And another surface area for bugs, obviously, when you're building a complex orchestration layer, the orchestration layer itself can be wrong. The contract to how all of these workflows and signals and events and whatnot work needs to be quite carefully thought through. But ultimately, once you've built it, it doesn't need to change much. Your agent can change and use that underlying orchestration layer differently without the orchestration layer itself having to change. So, I mean, how do we mitigate some of these pains? Well, I think like all things, you can mitigate this with tooling. So, we have basic scripts that can pull out what happened in terms of from a user session from our database, and then we can use that to link back to the temporal workflows. You could eventually build UI for this. There's also more traditional tracing and whatnot with OpenTelemetry or whatever you want to use. You can plug all that in and that still works just fine. I would say keep in mind that it's still quite tricky to link different workflows that are dependent on each other together. Observability tools are generally not designed for, very long running workflows. I mean, thanks. That's pretty much it. Short and sweet. If you're interested in what we do at Architect, you can't sign up just yet. We're still working directly with customers, but if you're interested, you can visit us. You can book a demo with some of my co-founders at tryarchitect.com. Thanks.
All right, thank you, Luke. I thought that was a really great talk. We are going to move over into the Q&A. So I'm looking at the chat, and we'll use the chat to manage it. So I'm mostly just vamping here to give you all more time to give us questions as well. So I guess we will bring Luke and Simon back up. Luke, I guess, never stepped down from the virtual stage here. But Simon, I think the first question is for you. This is from Lautaro, and I'm sorry if I didn't get the pronunciation quite right there. They asked during your talk, is this different from sending signals?
Yes, it is.
And maybe for the people that joined a little late, you can give a bit of background about the context of the question too, since
Yeah.
we've had a few more people pop in since your talk.
Yeah, so in the demo, the Temporal has three ways of querying the state. And I use the word query probably wrongly, and that is updates, signals, and queries. Now, I was using queries to get the state and to effectively to do a read query on it. And then I was using an update to do a read write query. So an update, it sends in some data, it validates it if you want it to, and then it returns a response back. With a signal, that's only a read example. So the way to think of it is that queries are read only. Queries are read only, signals are write only, and updates are read and write. Now, updates are a relatively new addition to Temporal. So we used to have to use a signal, and then you'd immediately have to call a query to see if it had been accepted. The update solves this problem, because if it fails at any point, we return an error, which a signal doesn't return an error from. Basically, it's fire and forget.
Perfect. Thanks, Simon.
All right. Next question. Is a workflow double equals a single architect website user session, or is it more like a graph of all the possible user sessions? Luke, this one's for you.
It's kind of both. Like I say, we do a lot of pre-computation to make sure that when you first land on the page, it loads up instantly. So the initial load for any given session is always pre-computed. And then as the user traverses that graph, that doesn't require any temporal workflows. And then if they ask something live, then we can start spinning up state nodes ad hoc.
And then you've got a bunch of questions. Next up is why temporal in Tri-Architect? Is it working just as an orchestration tool, or are you using it for the retry policies?
All of the above. Like I said at the start of the talk, like the building agents and productionizing them and operating them is very hard because there's so many failure modes, and a lot of them you're not in control of. It's very, very coordination and I guess glue heavy, more so than virtually all other kinds of things. And Temporal gives us a lot of benefits in this regard. One is the failure or robustness to failure. The operational aspects are really good. And there's a lot you get for free out of the box where you can see what's going on with the event history. And it also means that recovery from failure on our side, whether that's particularly server failures of the workers, is very easily recoverable. So we don't write any code in our agent that thinks about failure. There are no error handlers, there's no try catches, there's nothing in the agent itself, because we can just let it fail and then the temporal handles everything under the hood for us.
Yeah, that's ballsy. No try catches at all, but I guess we'll take it. So Jurgen was curious about how you connect to human operators to get things like approvals or other kind of feedback. Does Temporal provide a framework for this?
No. So basically, the idea with Temporal is that how you connect to it is your decision. The Temporal SDK has various helpers that do things like that. So if, for instance, you're using the Golang SDK, it's just the send query. If it's TypeScript, it's a similar send query type thing as well. If you want to do it, say, like I did in a web application that receives events like that, then that's outside the scope of Temporal. So the way I did it was a fairly brute force approach, in the sense of it was just polling every 5 seconds to go and get an update in the query, and then it was reactively making a change. if you're going to do this in a production application, what you probably do is wire up a WebSocket, and you'd have that WebSocket connecting into Temporal to say go and query this information. So yeah, that's sort of outside the scope of what Temporal does.
Yeah, yeah. I saw this really interesting version where they had a scheduled job that would use a signal to essentially interrupt it to like cancel like a reminder. And so that was an interesting version of
Yeah.
this that I saw that I liked. So
One thing that actually, so this is sort of slightly off topic, but one
yeah,
thing that I really like about Temporal. So historically I've done a lot of TypeScript and a lot of Golang, and
yeah,
I tend, not always, but I tend to sort of think of it, if I'm doing something which is going to be exposed to the web as either an API or a front end, I tend to use Node.js for that because I can use things like WebSockets and it's nice and easy with events. And I tend to
yeah,
use Golang for the back end computational stuff. Now, I know you can use WebSockets with Golang, but because Golang is not designed like JavaScript as, or Node.js as an event-driven thing, I tend to find it a bit more complex to do it. With Temporal, I find that actually I can do those event-driven things in Golang if I want to, and it's a lot easier than
yeah.
having to work out how to set up a WebSocket in Golang.
Yeah.
They're
Yeah, no,
probably
I've been
more intelligent.
doing similar stuff in Python and Python, but I end up having to use front-end JS just to manage the receiving of those WebSockets anyway.
Yeah.
So yeah,
I know you can use WebSockets in Golang and Python and all of
yeah.
that, and it does work and it's fine. But it's
It's a
personally,
second class citizen, and you probably still
yeah,
need the front-end JavaScript anyway, just to, get it rendering on the client.
exactly, yeah.
Yeah. Okay, next question from Oleg. What about the use case when workflows may contain multiple human-involved steps? Example, you need an approval by a manager, approval by a budget owner. On each of these steps, the action might be approved, deny, send back. We want to have those steps configurable and reusable to plug into various workflows and customize per customer basis. Are there any examples on how we can achieve this with Temporal?
I haven't got any examples offhand. There might well be examples, I'm just not aware of them. In my mind,
Yeah.
the example that I gave it was going to have multiple human involved steps. Obviously, because I'm just one human, I was doing this as a demonstration.
Yeah.
I'm pressing the same button each time. But in my mind, from a demo point of view, this would be, you'd have somebody who's in charge of the restaurant would say, I accept this. Then that goes over to the kitchen and the kitchen says, we've started this process. Then it goes to the delivery people and said, yeah, we've started delivery. And then it's obviously been passed to the customer. So they're all, in my mind at least, they were all different user steps. Now, if you want to say that they then do different things. So in my mind, so in the example I gave, basically it was update status, and then it sends a notification. The only exception being the rejection, which it also then refunds the money as well. So actually, from a temporal point of view, you can do as many updates as you wish. You can have, and initially I was going to do it where you would say you'd actually start a workflow and then you'd add your food in, and you'd be able to
Yeah.
keep adding things to your order if you wanted. It sort of slightly didn't explain the process too easily, which is why I changed it. But you can have as many updates as you need to do that.
Yeah.
Um,
Yeah, it might be cool to like get if you're able to add a second step and then toss it up on the code exchange as well. And so then we have an example that's purely about this specific kind of flow up on the code exchange for folks to look at if you've got bandwidth for that. Not to put work on your plate.
yeah, genuinely, I don't have bandwidth in the next month. I've got partly because I'm also going on holiday.
Yeah. Oh, well, we can't stop the holiday. Those are important. All right, Dave. Dave has a question. It seems like a downside of leaning on temporal is to keep track of the individual states of a conceptual workflow. Is that it isn't easy to observe the states of all workflows in the large. For example, if I keep track of individual states of purchase orders as records in my own database outside of temporal, now I can run queries in aggregate to understand, for example, what percentage of orders are pending. Do you have any thoughts on how to accomplish things like this if you're filing a patent like the one shared today?
Yeah, you are right there, Dave. If you use Temporal to manage effectively as a database, now for the record, I did do that. It's fairly terrible. And the reason I did that was because, again, just for the demo purposes, I didn't want to stick a database in. But what you would do in this case is you would actually, when you receive the update, so the update basically just changes the, I'm going to call it in memory state or in workflow state. But you could then also get it to trigger an activity to say, save state to database. So at this point here, when the state is saved, or when the update is received, it then makes a database trigger to say, also save this, persist this state to the database. So yeah, having Temporal as managing your data, it's not a brilliant idea. It's not what Temporal's designed for. Absolutely stick this in a database. And then, as you say, you can run all these agri queries to understand all that thing. Because for the purposes of my demo, I'm only going to do 1 or 2 examples. It was fine for that. But yeah, it's a fairly terrible idea to store long-term data like that in Temporal, because it's not what it's designed for.
Yeah. I like Dave's response here that makes sense, and so you can have your cake and eat it too. And he
What
says
type
thank
of
you
cake
as
are you
well.
having, Dave?
Yeah.
I want to know what cake you
Maybe
want.
while Dave decides the cake, we can take the question from Warren, which is, oh, Dave says cheesecake. Warren asks, temporal agents have limits to history storage, correct? Would anyone like to comment on the approaches to maintaining that history once you hit the upper limit? An AI agent might want historical data beyond what an agent can store, I would imagine.
Yeah, I mean, so the short answer is yes, correct, Warren. They do have a storage limit. I can't remember the number. I think it's about 60,000. There is a whole process of continuous new, which is effectively that's the architect's conversation, which is you need to go and look at the continuous new, and then you would be able to set up a different workflow based from a specific point in there. But I'm interested, Luke, have you got any real world examples of using that?
No, we don't use continuous new. Like I say, because we keep all of the workflows very short running, we'd never run into this problem. And I didn't actually talk about that or put that in the slides, but yes, that's another reason or another consideration when designing your workflows. You do need to think about this very explicitly. I mean, to be fair, like with an agent, you don't want it running too long with a massive context window because it's often going to lose trajectory. So you're already thinking when you're building your agent about like how long the history is for the same reason in the same way. So however you're managing compaction or however you manage state in that way, you can probably align that with how you design your workflows.
Yeah, that's great.
All right. I am not seeing any more questions, so I'll give folks a little bit I'll vamp for a minute or two just to give folks one last chance to submit anything. Simon, Luke, did you all have questions for each other? I guess is a good check, since you were watching each other's talks and probably didn't have time to put questions in the chat.
I've not got any.
Yeah, I mean, I suppose you covered it slightly. It's more interesting. So, what other alternatives did you consider a Temporal when you set up Architect?
There's no alternatives to Temporal that I particularly considered or thought of. The alternative is to do this in the traditional way. So the traditional way would just be, you need to drive all of your state management when your agent is in flight or processing something off of the database. So the way people do this with whether you're using some of the popular agent frameworks or building it yourself would be between every single LLM call you snapshot the state and then you like do the LLM call, write the state back. You end up doing a lot more database writes. The code gets a little bit like trickier. I mean, it's not a massive difference, but you don't get all those things for free with Temporal, like you do with Temporal.
Yeah, I guess to a certain extent, your answer is effectively based on the question that Dave sent, and that's the alternative is what Dave was proposing with the database, and you basically just looked at that and said, my answer to Dave.
Yeah, I mean, we rely on Temporal massively for a whole load of things, and so it also makes sense to try and bring the agent stuff into that. We have other stuff going on in workflows, and then the workflow communication between each other is also quite good in Temporal.
Great.
All right. We've got like 10 minutes left in the meetup. And so Simon, I figure if you're up for it, I think it'd be nice to do a little roadmap preview.
Yeah, so we did this last time. This is more of I mean, very welcome to ask questions in the chat, but this is more just like a news headlines almost of what's been put into the Temporal roadmap. There's actually 4 stages now in this roadmap. Generally available is exactly as it says. That's available for everybody to use.
Yeah, Simon,
Pre
did you want to share your screen here?
I
Or
haven't got anything to show on screen.
all right, just checking.
Yeah, there's public preview, which means that it's available. It's not sort of necessarily as fully robust, and it may change, but it's available for you. Pre-release means that it can be enabled and you can use it, and again it can be susceptible to change. If you're using Temporal self-hosted, that means you've got to add some configuration to get it to work. And if you're using Temporal Cloud, you need to come talk to us and raise a ticket to say, hello, can I use this on my namespaces? And then roadmap, which is the new one, which we've had since last month, which is just, it's been added to the roadmap and it will happen at some point in the future. So in generally available things, we've got multi-region replication. That's replication between regions in the same cloud provider. Service accounts, that is support for accounts that are not used by humans. So if you Kubernetes instance, for instance, you want to be able to connect to Temporal Cloud or Temporal self-hosted, you would use that. Worker scaling, you can expose queue statistics so that you can decide whether you need to scale your pool up or down. That happens automatically. In public preview, we've got skim support, which is added skim capability to SAML-enabled accounts. And I've lumped these two together because they're slightly different, but they're also slightly the same. We've got same region and multi-cloud replication. So same region means if you're in one specific region, you can get a replica in that same region. And multi-cloud replication means that, for instance, if you're using AWS, you can also replicate that over into GCP as well. Private connection enhancements, we've got various different private connection enhancements so that you can lock down your temporal workers to show your temporal connection so that it's can only go over your network. And we've also got namespace tag, which is a really tiny thing, but it's so useful because we can have tags on the namespaces so you can, if you've got 100 namespaces, you can just go and search for them really easily. And that is actually my favorite one that's come on recently. In pre-release, we've got a self-hosted to cloud migration so that if you're a self-hosted user, you can easily migrate onto Temporal Cloud. And again, these two are often coupled together. We've got priority and fairness. So priority is you could order things so that they happen in a specific order. And then with fairness, those things are ordered, but they don't all happen in the order. You get a probability so that if you've got somebody with low priority, they will eventually get served so that it's not, they don't get swallowed by the bigger boys. And things that have been recently added to the roadmap, Azure support. So we've currently got GCP and AWS. We've added Azure into that. We're also doing some upgrades to support large payloads. People who've used it regularly will know that we have a 2 megabyte limit because of the gRPC rules or the spec underneath. And finally, we're doing some work on the OpenAI TypeScript API integration. So if you like using OpenAI stuff, that's coming to our Temporal SDK soon.
Amazing. Thank you, Simon. All right, I guess I haven't seen any more questions come in the chat. So thank you all, everyone, for joining the meetup. Really appreciate you all being here. We are going to post the recording of this up on YouTube in a little bit, and we'll be pushing out info about the next meetup in a little bit as well. So
yeah,
keep an eye out for that.
The next meetup, it's probably going to be in November, which is why I sort of intimated earlier, I've got a very busy October and I won't be able to find the time to put this together in the way that I have done previously.
Yeah, didn't want to say a date because we still have to decide it. So as well.
Just to say a thank you, we will be doing a copy voucher giveaway, so I can share my screen quickly and we can spin two names if you guys don't mind before you drop off.
Let's do it. Yeah, if you want to, let me unshare my screen so you can take over.
There we go. There we go. So Antonia is our first winner. if you don't mind putting your email in the chat, I can coordinate your voucher in your region to the value of $20. And we'll just do one more. Jagadish.
Congratulations.
Thanks, guys. So yeah, just if you don't mind popping your email in the chat, I can coordinate your prizes to get to you.
Yeah, and you
Otherwise,
could
I
DM
can put
Natalie
mine in.
directly
Yeah.
as well if you don't want to.
We should have the
Yeah, we probably
emails
do.
on the sign up list, don't we?
We probably do, yeah.
Good.
Yeah, we should be able
Yeah,
to get them from
lots.
Luma.
Cool.
All right.
Thanks.
Anything else, or hopefully I didn't forget anything else.
Not
No,
that
I
I'm
think
aware
that's
of.
everything.
All right, just forgot one thing. Not bad for first meetup. So yeah, thank you again, everyone, for coming. Thank you, Simon and Luke and Natalie, for participating and for presenting. Really appreciate you all being here, and thank you all the attendees who joined, who asked us questions, and I guess thank you to the people watching this retroactively. I hope you enjoyed it and watched on 1x speed in the way that it was meant to be watched for the YouTubers, I guess. So thanks, everyone. I will let you all go, and we'll see you in November. Bye.
Bye all.
Bye all.